Yeah, okay. I'm so sorry,
Okay.
guys.
Good.
See you guys. Maybe
See
part 2
you.
or something. Hopefully it
Yeah.
all.
Bye.
Just stay looked out tomorrow. If nothing changes, you should see why I'm very busy on the news. From
Okay.
GovTech. Okay, see you guys.
Yes.
Bye.
Looking forward.
Bye-bye.
Bye-bye.
Bye. Okay, so well, I noticed one thing like when Janice and then later Stanley talked about. So even though the chapter section is called the basic tools, it's actually a lot to do with the mindset as well. So and over here, yeah, so this obviously pertains more to like developers and people working with the code closely. And one thing which is common between all of these things, so was the fact that like the author wants you to kind of give yourself more time to think, give yourself more time to actually think about it rather than think about what you're doing. So like there are broadly three different categories he considered. So one is purely productivity. And in productivity itself, he talked about the fact about like, for example, editor fluency, which resonates with the fact that, you know, like as a developer, do you actually have like shortcuts so that when you want to perform an action, like manipulate a file, even like copy paste text, you have that at the, like, you know, at your fingertips. So you don't have to actually consciously think about doing the action. So, and at the same time, he talks about text manipulation, because as a dev, I also find that sometimes I might need to copy over like property names, either from the data access object to maybe some front-end model view controller, but the property names are still the same. So in that case, I find that some tools like maybe Sublime Text, which allows me to easily replicate certain names and things like that, quite useful to me. So broadly, the authors like to talk about certain tools, and like I have tried to summarize it. And so in terms of productivity, we initially started talking about plain text over binary file formats. So like for me, because I work mostly in web development, I have not used binary file formats at all. So even when we worked with front-end teams and when we want to establish an API contract, we just stick to something like JSON, which is very easy, which can be easily parsed. And in cases where maybe they want, maybe they're just doing the UI, we don't have the APIs ready yet, we can actually provide them a very skinny API, which can just return the data format when the endpoints are called. So then we don't really block each other. So, and then we can focus on other things like that. So another benefit of plain text, as the author says, is it's just very readable compared to basically if you have very poorly named XML files and things like that. When you look at a plain text, the property names are usually well defined, so you can look at the data and know what to do with it. Then they talk a lot about using the shell. So for me, like one of my happiest days was when Microsoft announced that they're going to enable the Linux shell inside Windows itself, because I was very familiar with Linux shell, and for some reason PowerShell just is beyond me. And I find that it really helps a lot when you can, like, you know, if you want, like, for example, a really good example is if you want to enforce some API contract, if you want to enforce like coding conventions as well, or if you want to know something like what are all the packages my classes are using, you can literally, you can very easily find that using like a few lines in like PowerShell, and you don't even need to have Visual Studio Enterprise and all of those tools. So for manipulation and things like that, the shell is really useful. And also, like, for example, Sake scripts for like people who are in the .NET community, which can completely build, deploy your project. And like it's all just one PowerShell file. You don't really need to worry about the internal workings of it. So they just take a lot of work away from you, and they help you, like, you know, keep deploying faster. Like if you have to like deploy to multiple environments for testing, especially if you're working with different teams. So yeah, so that's about productivity. So from this, what I mainly got is the less you think about what you're doing in terms of the tools you're using, and it talks about mastery of the tools, so that you can actually focus on the business problem you are trying to solve. And you can think more in terms of maybe architecture, or more in terms of like what are the big picture, instead of focusing too much on like the work you're doing. So your typing becomes like, you know, you're subconsciously doing like the typing and the editing, and you're more focused on the business problem. So like some of the examples of the book which I quoted, like they were really powerful. So I guess it's they also like say like using macros and things like that. And about one way to achieve this is basically look at the work you're doing and note it down and think about what are the steps you're repeating yourself. Like if you're like constantly opening your like if you're constantly resetting some data in your local database, can that be done with the help of a click of a button, or can you create a macro for that? So it's like a step-by-step process, which just helps you in your own workflow. So the second thing they move on for the tools is basically the debugging mindset and approaches. And I work with a lot of legacy code in my company. And for those who do, so like sometimes obviously when errors throw out, when you have a large code base, you don't really know when to start, or like you just have a huge amount of error messages. So then in the debugging mindset, he mainly talks about how to deal with this situation. So firstly, like he talks about the mindset where basically you should not panic, and you should like, obviously, and you should like focus on like trying to solve the problem instead of trying to play the blame game or trying to find out which team is responsible. You just look at the task in hand and look at it as problem solving. That is essentially the mindset he wants to talk about. For approaches, there are a few methods, of course. One of the interesting things is, okay, so for people who are very familiar with binary search, he talks about the same thing in terms and calls it binary chop. So when you have an entire stack trace of 100 lines, or when you have a lot of error flows, he talks about like, when you're looking for a particular error message, use the binary chop approach, which you divide the error like stack trace into half, and then you go one way. And then like it's just to like, in the same way as it takes log n time to technically find your like the particular area you're looking for maybe. So like that's something interesting like which he talked about. The other thing is for debugging is there are two types of like errors which might happen. So one time it might be a system error, like where basically your configuration went up, maybe the database went down or something like that. And those like, or maybe a dependency, which was another project. You don't even know that your project was depending on this legacy project and it goes down and your project never handled the error in a proper way. So that might be a crash. And the other way is basically maybe it's just spewing out the wrong value, or like maybe there was some decimal errors and things like that. So he talks about really isolating changes like that. And finally, like of course, he talks about writing your own logs and putting in logs throughout the entire code path so that you know exactly where the code executed until if there was a lack of logging initially. And like, of course, I find that quite useful to do that when I'm working on legacy code. I think it's very important to clean up after that, of course, otherwise your log files are going to be populated with that forever. The final thing he talked about a lot was rubber ducking. For rubber ducking, it's a very simple thing, is like when you see a problem, try to explain it to another person. Like you can think about it as explaining to a rubber duck. So this person or this object does not have to respond or anything. They just have to nod their heads. That's what they say in the book. And the idea behind that is once you're talking about the problem, you tend to think about it from a different angle, or you get more time to think about the problem because you're explaining it. And then eventually you might actually find something, like because it's just a pattern, like you're trying to change your angle of approach. So like that's to do with mainly the mindset. Like you would notice that he doesn't really talk about a specific tool or a specific thing. He does mention for text manipulation, there are some languages, like for example, like Perl is very good at text manipulation, but at the same time, the entire focus is on mastery of your process rather than actually getting bogged down by a particular framework or a particular tool. He just focuses on what you're more comfortable with to achieve the same result and mastery of that. And lastly, he talks about change enablement. So for version control and for like an engineering logbook. So I think most people, most developers are using version control, but he goes far further than that to say that, for example, even if you're working on a throwaway piece of code, to use version control like as well, because it like for one thing, it like of course you're going to throw it away, but at the same time, it acts as a log. And when you end your commit messages, if you're actually writing them properly, you can actually refer back to your thinking. So you don't have to rely on the most unreliable like source, which is yourself. So because you will forget as a developer, but your change sets will obviously have the recorded information. So even for throwaway code and things like that, and of course, like source control enables us to go beyond and do like Scrum practices and Agile practices, like continuous delivery, continuous integration, and also it enables, and also because of today, there are hooks with Slack, hooks with Jira, so you can actually integrate your entire workflow with all these tools, so that the moment someone releases or a status changes, you get notifications everywhere. So especially if you work in a large distributed team, this helps a lot. And the engineering logbook is literally the simplest thing, the simplest tool he talked about. And the story he mentioned over there was he noticed when working on it with a like manufacturing firm that engineers go about with a little notebook and they constantly write things down, and that's it. So every engineer has a record of things they observe. How this helps them is if there was some decision taken, or if there was some defect they noticed, or if there's some ideas they had while looking at a process, this becomes their point of reference. So it's just a quick record. He specifically talks about doing this on a physical notebook instead of using a smart device or a smart tool like that. And because it's just faster to do, and then like the author really enjoys the fact about you're writing on something rather than typing all the time. So yeah, so for that's mainly for the highlights. And for Stanley, if you could just change to the next page. Yeah, so parts which resonated with me. So like some of the things I like agree with is editor fluency. I am no means the fastest typer out there, or like I wouldn't like claim that I have completely mastered the process, but it's really cool to think about like slowly improving your process one bit at a time. Same as what Janice said about being 1% better. And like some of the things, like they say, like, if you are one shortcut, if you want to use how to navigate between different functions using shortcuts, or how to collapse your entire window, open it, navigate between files quicker. So like that is something which gradually, maybe even one shortcut, if a week you learn that, at the end of the year, you have 54 shortcuts at the tip of your fingers really ready. And for debugging strategy, like of course that resonated with me, because like working with legacy systems, like the mindset and the approaches he talked about, yeah, I have used some of them because I had to learn them, and like the entire approach of being calm is really important. And for version control, I have my own story in that case, because I found that when I was using version control, we were working on this improvement of a very specific transaction branch. And what we could do is basically every single change we made, we could put it into version control. Another developer could just release that branch without having to wait for us. And since everything was on GitLab, they could release it to their own environment, test it, and then they just report the findings themselves. It was a very decentralized process. And for engineering logbook as well, I use the same thing. It's very useful for jotting down ideas and decisions, and also explaining things to people. So it all goes with mindset and some tools and mastery about your own process, rather than any framework or any language in particular. Yeah, but that's it from me.
Okay, I'll go to the next slides. Vijay.
Hi, just to be honest, is it audible now?
I'm sorry?
Am I audible?
I can't hear you.
Am I audible? Okay.
Yes, I can hear you. Yeah.
Yeah, my slides are a little wordy because the first time I read the book has a lot of statements are there in that book. So I just want to keep them as it is, but to be at the chapter highlights are the topic 24 to 27, but I put it in very bigger letters. So what the author is trying to say is when we give the writing code or software to a developer, they expect to write a perfect code. That means they put a lot of statements, or they put a lot of conditions, and try to impress that they are the best while writing the code. But what the author believes is that yes, you can write a perfect code, but when other people's code, it may fail. So what he's trying to say is, don't go for perfection. Go for how you solve and how you put that piece of code in a chaos code that's already working in production or in software already there. So that's why don't trust yourself as a good programmer, but try to write a code in such a way that that the code works with the other pieces of code. That's what he want to say. So don't go behind the perfect software. And the other part he's trying to say is, when you write code, people try to write code, they will take, for example, if there is a function in any of the programming language, it will take some input parameters and it will try to give some output, maybe a piece of processed code as an output to it. So, but in between this input and output, you may have a lot of conditions, which are preconditions to accept that input, or post conditions before you process the data. And there may be some of them for variables that are changed in between those things. So you need to define the contract in such a way that whatever input you take, you try to process that input only. Do not try to add more functionality already accepted contract. What happens is, when you try to write more functionality in it, for example, you have 5 parameters, but you try to use only 3 parameters, and you don't use the rest of the 2 parameters, but you write a code in such a way that you write for the 5 parameters, then it will be a lot of code which is unused code that is there inside the system. So what he's trying to say is, whatever contract says for that functionality, stick to that functionality. Don't go beyond that one, or don't undergo what that functionality is accepted for the contract. So that's what he says, that be strict in what you will accept before you begin, and promise as little as possible in return. That's what the statement is really true. Because when you work with developers, they try to take as much of parameters as possible, and they try to leave the unused code in the same function itself. So when you put the unused code, then the number of cycles for the processing, that is also get processed, or that is also get built inside the system, which is already unnecessary piece of code which is not used at all. So try to minimize that one. So whatever you accept in the beginning, try to process the data and as possible with that process data only. That's what he's trying to say. So is any questions on this slide? Then I try to explain that one. So that is by design with contracts and design by contract. So you stick to that functionality. So when you what is trying to say, that is easy for you to write the test scripts also for that functionality. Suppose you are expecting A plus B is equal to C. Try to take A and B only and try to produce C. Don't produce D and E and F also with that A and B. So don't write extra code, or don't underwrite unnecessary code. So that's what is the first tip that other has saying. That is totally true also. Can you go to the next slide?
Okay. Oh. Oh. It seems that okay. It seems that Vijay has dropped off. Let's wait for a minute to see if he could get back up. Oh, okay, he's back here.
Yeah, I'm back.
Hi, Vijay.
Hi, are you able to hear my previous statements, or is it got disconnected somewhere in the middle? Right.
Just right after I switched the slides, you drop off.
Drop off. Okay, no issues. So the next point is talking about, the author is talking about dead programs tell no lies. That means when you see, there is a in a normal developing world, when you develop a product, people might observe while you actually see, there will be a dump of web server statistics on the failed page. That means it will show you the version of the Apache browser, the version of the Apache server, the other software version numbers and all. That is very dangerous to open up your system to unnecessarily expose your software backend stack to the end users. So that's what the author is trying to say is when you have a dead program or a crash early and crash safely. That means don't expose your software or the code or the database versions to the end user. That's what he's trying to say. You can crash many times, but you crash it safely so that you don't expose your inner things to the outside world. So that is very dangerous for the system itself. So that some hacker may try to find bugs in that version of the piece of code or a piece of libraries that you have, and they try to exploit that piece of software. So it is very dangerous for you also. That's what dead programs tell no life. So make sure that when your program is dead, it dies very safely. So that's what the other is trying to convey those things. Next one is assertive programming, and I think you already know how to use assertions and all because many programming languages have an assert function. For example, the major mistake developers does is sometimes they won't check for null values. For example, an array list or a kind of an array or a piece of Boolean values or a piece of string values or a piece of integer values. They won't check for null values. So when you are trying to expose that process that null values where you check null value, then the system will crash. Instead of that, you can put some assert functions which are readily available in the library. For example, Java, there is an assert function. Before you process that array, just try to check is the array null. If it is null, there is no point in processing the array itself. So it will save some time and it will also give some reliability to that software we develop. So that should not have any what you call burden to the system itself. So that you will try to stop the processing of the code when you think that it is null. There is no point in processing the code. So that's what asset will help you out. So that means you are building a product where you can it won't fail. Even if it fails also, it will actually show you where it failed and how to take the corrective action in the system itself, in the software itself. That's what this assertive program is all about. And also make sure that assertive program should not have any side effects. So that means you should use the asset when it is required, but not in every place unnecessarily. We can't put that. That's what is the other is emphasizing on that one. Similarly, the exceptions also. I will tell you one story what I faced in one of the projects that we have done. It's a huge airline website, and when we done an upgrade to their databases, we stopped one active database and we bought up the secondary database with the new version. And after that, we updated the master version also with the same version, and we bought the system up. But after it went well for 6 hours. After 6 hours, the software, the website UI is failing. We thought that it is the problem with the SQL Server upgrade itself. When we went and debugged the entire software packages and the library at the back, one of the developer forgot to catch an SQL exception. When the connection opens up, and when you need to properly close the connection once you've done interaction with the database. So when you open and you won't close the connection, what will happen is the number of open connections will increase, and it will try to create a heap memory. Then the heap memory will crash after a few open connections because the memory will not be available to the system. So you need to know how to catch each and every exception. So the moral of the story is, if one exception capture is also failed, it may create a problem for the entire software that is developed. No matter how much night outs you spend or how many man hours you spend on building the software. So be clear on what exceptions to use, when to use, where to capture the exceptions. When you capture exception, what is the follow-up action that you need to do on that for that exception, so that the software itself will not fail. Only the exception will fail. So that's what the author is emphasizing on exceptions for exceptional problems also. So when you are not expecting a exception, try to put exception so that the exceptions also, that software is made reliable while it is running in the production, so that it won't create unnecessary problems to the software or the user, end user. So that's what the other is telling, that make sure the dead programs are crashed safely. That will happen only when you capture the proper exceptions in the proper time. And also you need to make sure that assertions also will be readily available to you, so that the software is more reliable and you can do proper test driven things, so that the software is quality wise and makes it won't fail in the production system or in the runtime system. So that's what is the second point that author is asserting on. So any questions I can take, otherwise we'll go to the next slide.
We will leave the questions to the pigeonhole.
Okay.
There are a couple of questions over there. I'll go to the next
Okay.
slide.
We'll go to the next slide.
Yep.
So the next slide talks about your resources. So when you write your programs, when you start your programming, you need to finish the programming also very clearly. So when you start your program, there are 5 or 6 things that you already keep in mind. That is memory one that you're trying to use. That means you will allocate memory to your variables, and you will initiate transactions. When you initiate transaction, the threads will start invoking. The threads will try to bring a file or a database record, and there will be a timer for each of the transactions that you do. So all these things will be coupled into your software. So that means you are using a lot of resources, shared resources. And your main duty is, when you try to allocate a resource, once you use the resources, deallocate the resource also in timely manner. Otherwise, what will happen is, when your most threads started opening up, there is a proper chance of deadlock will happen in the system. If deadlocks happen in the system, that means there is a chance that your system will crash. So when you, simple thing is, when you open a door, try to, once you use the room, try to close the door. That's what we all say in our offices also. When you complete your meeting room, try to clean your whiteboard, try to put markers in the same place, or try to put your eraser also in the same place where it is to be, and switch off all your lights and all those stuff. That means you're trying to say optimize your resources once it is the usage is completed. Similarly, in the software also, same thing comes into picture. When you try to use your resources, try to use it optimally and try to close it optimally on time. That will help you to write a good code for you. So similarly, you can write wrappers for resources, so that wrappers will act as a proxy kind of a thing, so that you can accept more resources, more usage to that resources, that we can use it optimally. Similarly, that example he has given is finally to free all resources. So sometimes developers will capture all the exceptions, but they'll forget the final or the finalized block. So finally block will help you out to remove all the unnecessary open resources in the piece of code. Once you piece of code execution is completed, it will try to release that resources. It's done. The other point the other is highlighting is, don't outrun your headlights. That means don't overcommit, and also take small steps, and don't try to tell fortune telling in your piece of code. That means don't overcommit or don't try to undercommit those things. So that means don't jump the gun. Whatever is possible, try to achieve that only in that piece of time or in the piece of code. But don't try to commit extra and deliver lower, or commit something which is not achievable in that same piece of time or code. So that's what is the chapter talks about. The chapter talks about how to handle your dead piece of software, how to handle exceptions, how to utilize your resources, how to commit more work with less effort, kind of a thing. So that's all the chapter is talking about. But all are relevant to the software or product development teams. So it's quite on the ground approach that the author has taken to tell the reality of software developer, that about the people, the way they code. So that's it from my side.
Okay, thank you, Vijay. Let's see. Okay, this is the last slide. I would like to. So we have overrun by 4 minutes. I think what we could do now is that So we'll still hang around for another 10 minutes to see how much questions we can answer. Let me go to the pigeonhole so that we can view the questions. There are 3 questions here. Can you guys see the questions? So, yes. Good. Can you please appreciate you that you could actually vote which are the questions that you like to be answered. So I see that we have about 9 people over here. So could everyone please take a minute or two to vote so that we can know which to prioritize. Let's take a minute. We have 1 vote so far. For info, the URL, can I show the URL? Yeah, okay, we have another vote. Let's get a few more votes. You can find the URL in the group chat. Okay, I suggest we'll just start with the leftmost question. So the question is that if you catch a, let's see. Oh, I see. What is group chat history isn't visible to? Sorry, I'm looking at the group chat. Okay. Yes. Thank you. Okay. So now I just realized that not everyone, people who join later may not be able to see the Zoom group chat history. Thanks, RJ, for figuring out that. Yeah. So okay. I think we'll just continue with the questions. If you catch an exception, recover exception instead of an error that is unrecoverable. Isn't this using exceptions as control flow since the recovery logic is caught? Let me just open to the speakers. Would you like to answer that, Vijay or Adit?
Yeah.
Alex?
My view, I can tell that the entire idea of exception is to make sure that you control that entire flow of the logic that is happening. Yes, if that answer is it this using exceptions as control flows in the recovery logic is called? Yes, it's a kind of controlling your logic. That means it should not go into the wrong direction. Suppose if exception happens, it will crash. So when you catch an exception means you are trying to ensure that the software didn't crash and it will go into a side track where it will lead to some other thing. For example, imagine the user is browsing his website and he tried to click a product catalog and then the product is not found. So the best idea is instead of leaving the user at the not found screen, you ensure him to redirect him to some other place where he can still start searching for another piece of product. That means you are trying to control the flow of the user to the respective place where he can still start searching. Similarly, in the developer also, when you get an division by zero exception, instead of making the system crash, you direct that user to enter a new number, so that you will try to enter a new number and then you will try to get the divisibility function correctly. That means the entire idea of exceptions is to make sure the system is recoverable when an exception happens, and also the catch all exception is also there. So that unrecoverable, that means you are not anticipating that recovery also. You can capture that one, so that the system will not go into a crash mode. It will try to still function. So that's what is my take.
Okay. I have also some thoughts about this. I think there are different types of, well, if we were to, I could interpret it as there are two types of control flow here. One type of control flow is about business logic, which means that, example, if something happened, then maybe the calculation of the balance is different. So if we use exception handling, recover exception handling to adjust maybe the calculation, then that is probably something not we want to do, but rather exception handling would be to ask, it could be asking the user or the program itself to get back to a recoverable state. So those are the two different things that I see. So yeah, and yeah. I think let's move on to the second question, then we can end this off. The second question is, does knowledge in the heads of multiple engineers count as duplicated knowledge? That's an excellent question. I don't know. Like now there's this COVID virus. What we know about COVID virus, does it count as duplicated knowledge? Yeah. What I'm unclear is probably if I could ask more about this question, what led you to ask this question? Is the person that asked this question still here? Okay, William. Yes, that's the question. Could you elaborate a bit more of what brings you to ask this question?
So can you guys hear me?
Yes.
Yeah, so because you talk about duplicated knowledge, as in when you change it in one place, it's not updated in other places, right? So doesn't that also extend to people? Like if you had, let's say, 5 or 6 team members, and then one guy goes and change something, the other 4 or 5 people don't know about it, and then it changes your service, let's say. So that doesn't seem like a good situation. And how would we like try to solve that?
Yeah. I couldn't say from the book's perspective. I don't know if that is considered breaking the dry principle. But yeah, that's not a good situation to have, because if you're working together, your work is interdependent. Syncing up your information and knowledge is essential to avoid misunderstanding and also accidentally step on each other's toes. So one of the what I can relate is that to have a team working agreement saying that maybe it could come out from because of some cases. Then you share the cases that I noticed for the last 2 cases, there are some information that I don't know, and it has resulted to certain impact. I wish I would know more, have more when this change is being done that could impact other people. this information is being shared immediately. Can we have a working agreement like that within the team? This is something I can think of. Any comments from other people?
I just want to say only one thing: that knowledge is knowledge. You can't make it as a duplicated knowledge. When we work as a team, we'll all learn something out of that teamwork, and whatever we gain, it's one perspective of that knowledge or the work that we actually done. So it's not a duplicated knowledge; it's just a knowledge, and from that knowledge, I can either improve upon, or I can make it better out of that knowledge that I gain. So it's not a duplicate. Knowledge is knowledge. There is no duplication. For example, you know Fibonacci series, right? So whatever I write, Stanley can write the same thing. Maybe Alex also can write the same thing, or you also can write the same thing. That's the knowledge that we gain. But using that knowledge, if I try to invent something, that's up to me. That is the individual's perspective. But Stanley's knowledge and your knowledge cannot be, any other guys with the same Fibonacci series knowledge is knowledge only. It's not considered as duplicated knowledge.
I think
Hope I
that's what.
answered your question.
That is well said. It also reminds me about the perspectives. People come from can see the same situation differently, and especially if you are working together in a complex system or environment, not everyone have the same exact understanding of the situation or the context. They come with different perspectives on that, and often to solve the problems more effectively, it requires a collection. People will need to be able to see multiple perspectives of the same situation to be able to make a better judgment. So yeah, thanks for that. It relates me to this. Yeah. William, does this answer your question?
Yeah, thanks.
Okay. I think that's about it. We have overrun by more than 15 minutes already. Thank you, volunteers, Alex and Vijay and Janice, who has left already. Thanks for the participants who are here with us tonight. If you have any feedback, please feel free to write to me. This is our first time trying this, and after this, we will improve the online meeting. Thank you once again, everyone.
Yeah.
Good night.
Thank you a lot.
Thank
Good
you.
night.
Good night.